Hello guys, welcome to Nuanco Digi Lessons. In this video, we are going to study Class 9 Science Chapter 4, the structure of an atom. So these are the topics we are going to study in this chapter. Now, atom and molecules. Since we have already discussed about them in previous lessons, we will not get into that. So now moving on to the first and very interesting topic of the chapter, which is Thomson's atomic model. Now before getting started, let's discuss a bit about Sir J.J. Thomson. So Thomson was the first person to introduce a clear structure of atom. Though it was not a fully correct model, but at least somebody has started the journey. So what Thomson did, he compared the atom with the watermelon. We know that there are two charges in an atom, positive and negative charge. Thomson said that the positive charge in an atom is like the red part of the watermelon. It is spreaded in all over the area, and the negative charge is like seeds of the watermelon. It is embedded in the positive charge. So he compared the positive charge with the red area of watermelon and the negative charge with the seeds of the watermelon. So with the help of this, Thomson included that the positive charge is spreaded all over the area and negative charge is embedded in it. This is the first point of the conclusion of Thomson's atomic model. And the second point is both of the charges, the positive charge and the negative charge, are equal in amount. But as I said before, Thomson was not totally correct. There were some limitations of his model. So let's discuss about them. First of all, Thomson was not able to explain how the positive charge holds on the electron. That means Thomson's model could not explain that how does the positive charge holds the negative charge. And the second limitation was that it could not tell us the state of electrons. That means electrons means negative charge. So the sentence means that it could not tell us that the electrons are in state of rest or are in state of motion. So these were the limitations of Thomson's model. But this was not the end. After Thomson, Rutherford came up with his atomic model. Now, sorry for the gap, there was a background noise, so I have to cut the video. So, we are on the Rutherford's atomic model. Now, Rutherford took a gold foil and bombarded it with alpha particles. That means he hit the gold foil with a large number of alpha particles. Here one thing is to remember that alpha particles are positively charged, and the second thing is to remember is that same charges repel each other. That means positive charge does not want to come near to the positive charge and the negative charge does not want to come to the negative charge. So now when Rutherford hit the foil with the particles, he saw that most of the particles pass straight through the foil. Some particles change their path a little bit, and 1 out of 12,000 alpha particles appeared to rebound by 180 degree. Now let me explain you with a more practical and more clear example. Imagine that you are driving a car, and you can imagine only because you are under 18. So imagine that you are driving and there's a huge pothole on the road. Now there are three situations. Acha, imagine that you are driving and a lot of cars are also running on the road. Okay, and there is a huge pothole on the road. Now there are three situations. The first one is there are some cars which are not in the range of the pothole. So what will they do? They will continue driving straight. The second situation is there are some cars which are uh, which are close to the pothole. So what will they do? They will change their path slightly. But now you are driving in your own world of thoughts and you suddenly realize that there is a pothole on the road and you are just in front of the pothole. So what will you do? You will just brake the car. Sorry, you will not brake the car. You will press the brakes of the car and put the car into the reverse gear and take it back. So same conditions happens with the alpha particles. Okay, most of the particles pass straight through the foil, some change their paths, and 1 out of 12,000 alpha particles upward to rebound by 180 degree, that means reverse. Okay, so by these observations Rutherford concluded something. So these are the observations and conclusions of Rutherford. Let me explain you. The first observation was most of the alpha particles passed straight to the foil. So with this observation he concluded that most of the space inside an atom is empty. Okay. Now the second observation is some change their path. That means some of the alpha particles change their path. So he concluded that nucleus occupies very little space. Up now, let me explain what the nucleus is. Nucleus is the center of the atom, which is positively charged. So we know that alpha particles are also positively charged. So when they come in the contact with nucleus, they will change their path, and 1 out of 12,000 alpha particles appeared to rebound by 80 degrees, that means reverse. So he concluded that the nucleus is very small in size and all the positive charge of the atom is concentrated in the nucleus. Okay, now these are the three conclusions, or you can say the three basic points of the Rutherford's atomic model. First of all, there is a positively charged center in atom called nucleus. Second is nucleus is very smaller in the terms of size from the atom. And the third is electrons, that means positive charge revolves around the nucleus. Okay, but as we know, nobody is perfect, so there are limitations of Rutherford's atomic model. So the first limitation is, why do the electrons not fall inside the nucleus as a result of the attraction? So the Rutherford said to us that the nucleus attracts the electrons or the negative charge. So if it is so, why do the electron not fall into the nucleus as a result of this attraction? He could not explain that. The second thing is, how is the atom not destroyed? Because if the positive charge, that means nucleus and electrons, collapses with each other, the atom must be destroyed. And the third point is, how are the electrons arranged in the orbits or the energy levels? Rutherford said that the electrons are arranged in their orbits. Orbits means we will discuss about that in next upcoming videos. Sorry for that noise. Upcoming videos. So Rutherford could not explain that how are the electrons arranged in the orbits. So these were the two models, Rutherford's model and Thomson's atomic model. We will continue Niels Bohr atomic model in the next video. Thank you very much.